Hi everybody. Hi Shravani. Hi, good afternoon. Good afternoon. Shravani, I will give the notes, okay? Do not worry. Today I am uploading the notes, okay? Without fail. Don't worry at all. Yeah, definitely. So how is everybody doing here? How is everybody doing here? Shravani, I didn't know you were a 2020 student. Are you a 2020 student? Hello? Am I buffering here, guys? Am I buffering? I think I was buffering, right? So are you 2020 student, Shravi? I thought you were a 2021 student. Okay. Okay. So good afternoon, everybody. Welcome to today's revision session where we are going to do five advanced level questions from rotational mechanics. Okay, and let's try to do them, guys. I myself find this topic very, very hard, okay, but it has a lot of weightage, and so we are going to do five questions. We're going to try to do it as fast as possible, but see, as far as I am concerned, for me, understanding takes a little bit of time, so I might go a little bit slow, but we will make sure everybody understands, okay? We will make sure everybody understands. If you don't, then you can, unsubscribe. That's okay. I will. That's fair. That's very fair. Yeah. Okay. Anyways, so guys, let's start with today's class only. Let's start with today's class only. If you're new to this channel, my name is Aaditya Pandya. I'm your physics faculty, master teacher at Vedantu, and today we are going to do one shot revision of rotational mechanics, where we are going to do five advanced level questions. Okay. All right, guys. So let's do this. Let's do this. First of all, is this okay? Yeah, I think this is okay. Okay. So let's do the revision, guys. Let's do the no. It's now. It's okay. Now it's okay. Okay, let's do the revision, guys. Okay, five advanced level questions. So one second. Is my chat not refreshing? Is my chat not refreshing? I think my chat is not refreshing. That is a common problem with me. That is a common problem with me. Yeah. Oh my God. Yeah. That's exactly. Pradyuma is also there. Akhil Nayak is also there. Shravani Reddy. Yep. Yep. Okay. 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 Good. Okay, High Entertainment 2015. Thank you, Pradyuma. Thank you. Okay, guys, chalo, let's start. Okay, let's start today's lecture. Okay. So first question, guys. First question, we will start off with an easy question, a relatively easy question where it looks hard, but you don't have to do much. Okay, what is happening is in the figure shown below, we are given a spool. Okay, a spool is basically, I hope everybody knows what a spool is. It's basically a small cardboard on which we have a winded a coil or something. Okay, so we are applying force on the spool like this. Okay, you have to find the value of theta. You have to find the value of theta so that the spool remains at rest. You have to find the value of theta so that the spool remains at rest. Okay, now guys, remember, if I'm applying a force and the spool is remaining at rest, that means there has to be some force which is in the negative x direction as well. Can anybody tell me which is the force in the negative x direction? Can anybody tell me which will be the force in the negative x direction? Correct. Which force will that be? Which force will that be? That will be the force of friction. That will be the force of friction. That has to be in the left direction. That has to be in the left direction, so that because of this the net force will be zero and the body will stay at rest. Now you have to understand that since it is staying at rest, it is under rigid body equilibrium. Okay, so that means the total force is also equal to zero. Basically, the total force in x direction is zero, the total force in y direction is zero, and the total torque about the center of mass, if you calculate, that should also be zero. Total torque about center of mass, if you calculate, will also be zero. Okay, so now first things first, guys, let's try to use both of that one by one. Okay, now the force in y direction will be zero, but that is not going to help us in much, so we are going to ignore this for now. Okay, because it's not helping us much in any way, so let's ignore this for now. Let's just do the first thing. Let's just apply the first condition. Okay, Dr. Mohammed is asking how, because Dr. Mohammed, the question says the spool remains at rest. Okay, the question says the spool remains at rest. So I'm going to start with the assumption that the spool remains at rest. It can only remain at rest if the forces and the torques are zero. Okay. All right. Okay. I hope everybody understood. Hi Hina, hi Dr. Mohammed, hi Jojo is also here. Okay, now so let's start with the first condition. See guys, I'm saying zero because the question says the school remains at rest. Okay, the question says the school remains at rest, so we'll start with that condition. Okay, for whatever that condition is, we don't care. Now, the first condition is that the force in the x direction is zero. Now, if you resolve this force F into x and y direction, then its component along x direction will be how much, guys? Its component along x direction will be equal to F cos theta. And its component along y direction will be equal to how much? That will be equal to F sine theta. Now, if I'm saying total force along x direction is zero, basically I'm saying that the force towards left direction should be same as the force towards right direction. The force in the left direction should be same as the total force towards right direction. If I write the values, I will write F is equal to F into cos theta. F is equal to F into cos theta, where capital F is the force we are applying and small f is the friction. Okay, small f is the friction. Please remember this, guys. This is friction. Okay, I hope everybody understood. Really hope everybody understood. Really hope everybody understood. Okay, now this is the first equation. We will remember this. We will come back to this. There is no issue at all. Let's talk about the second equation, guys. Let's talk about the second equation. What is the second equation? The second equation is the total torque about the center should be equal to zero, because this body is not moving. It is also not rotating. Now, if you see, there are two torques about the center. One torque is clockwise and the other torque is anti-clockwise. So what I can say is that the total anti-clockwise torque about the center should be same as the total clockwise torque about the center. Total anti-clockwise torque should be same as the total. So hi Manish Pandey, hi, hi, hi. Oh my God. Dipanshu from class 9 is also here. Dipanshu, see if you can understand. These are advanced level questions, my friend. I don't know what will happen. Okay. But the total in this case, guys, I will have to say the total clockwise torque should be same as the total anti-clockwise torque. Now, if you see, this force F is trying to rotate this body anti-clockwise direction, and this friction force is trying to rotate this body in a clockwise direction. Okay, the friction force is trying to rotate it clockwise and the capital F is trying to rotate it anti-clockwise. So I will write in both the cases R a perpendicular into F is equal to R perpendicular into F. Okay, now for this force capital F, okay, for this force capital F, what is the perpendicular distance, guys? What exactly is the perpendicular distance? So if you see here, this force is already tangential. This force is already tangential. The perpendicular distance will be this only. The perpendicular distance will be this only. Okay, you see this angle is 90 degrees. The perpendicular distance will be that only, which is r only. And similarly for the friction, guys, if you see, this is once again tangential, so it's already, the perpendicular distance is very simple. It's equal to capital R. Okay, so substituting both the values, what I can say is R into capital F is equal to capital R into small f. Now, small f we had calculated as f cos theta, so which I will substitute here. R into capital F will be equal to capital R into f cos theta, which gives me, guys, cos theta is equal to R by R, which gives me very simply theta is equal to cos inverse R by R. Okay, so if you go back to the question asks find the value of theta so that the spool remains at rest. What will be the value of theta? Theta is equal to cos inverse R by R. Guys, if you understood, please give me a thumbs up. If you did not, please give me a thumbs down. Okay, all right, guys. I hope everybody understood. Okay. Alright. Okay. Hi Akash Dev. Hi, hi. Okay. I hope everybody understood. This was a hard question, but we sailed through, guys. We sailed through. Very simple. We just applied a concept of, we just did the force equilibrium and torque equilibrium, and we got the answer. Force equilibrium, torque equilibrium, we got the answer. Okay. Force torque equilibrium, we got the answer. Okay. Let's look at the next question, guys. The next question is, it's such a khatanak question. It's such a khatanak question. Okay, so Akash Dev wants me to explain once more. Akash Dev, can you please look at the see Akash Dev? I will just explain in short. I just said that the total force should be equal to zero, gives me first equation. Then I said the total torque should be also equal to zero, gives me the second equation. Okay, using both these equation, I can get cos theta is equal to r by r. Then it becomes very simple. Okay, hi Sumit, hi. Okay, I just have to apply these two equations. Akash, now you will have to learn how to calculate torque. If you want, if you don't know, then watch my video on how to calculate torque. Okay, one shot video on torque. Now, guys, I have a thin rod. Now, this is a question. Okay, so I have a thin rod of length L and mass M, which is placed at an angle theta to vertical on a horizontal frictionless floor and released. You have to find the acceleration of center of mass and the angular acceleration of the rod just after its release. Just after its release. Okay. Now this is a very khatarnak question with no diagram given to us, guys. With no diagram at all given to us. Okay. So first thing we will do is we will make our own diagram. What we have is we have a rod of length L and mass M on horizontal frictionless floor at an angle theta to the vertical. So I will just make all of this into a diagram. Okay, I have a rod of length L mass M at an angle theta with the vertical on a horizontal frictionless floor. Okay, on a frictionless horizontal floor means it's on a smooth floor. All right, guys, this is the situation. This is the situation. Now, if you look at this situation, what they've said is that after I release this rod, you have to calculate acceleration of center of mass and angular acceleration of the rod. Now, in general, guys, such questions are very complicated and tricky. But what we are going to do here is we are going to use a shortcut called instantaneous axis of rotation. Now, how many of you know instantaneous axis of rotation? If you know, please give me a thumbs up in the chat. If you don't know, please give me a thumbs up. Do you guys know the concept of instantaneous axis of rotation? If you know, please give me a thumbs up. Hmm? Hi Ritesh Pathak. Hi. Do you guys know instantaneous axis of rotation? I don't know if you guys know it. Do you guys know? Do you guys know? Do you guys know? Oh no. Nobody's giving me no. Okay, so nobody knows instantaneous axis of rotation. Okay, guys. So let's talk about what instantaneous axis of rotation is. Okay, let's talk about what instantaneous axis of rotation is. Very simply, guys. Very simply, let's say I have a body like this. Okay, and I will talk about a general body here. I'll talk about a general body here, but let's say I have a body like this, okay, a random body, and I will just take two particles on this body. Okay, I will just take two part. First of all, let's assume that this body is hinged, guys. Let's assume that this body is hinged. Let's say this body is hinged about this point. Okay, now if I take two random points on this body, first point and the second point, and if I ask you the velocity of this body, okay, when the body is rotating, okay, if I ask you the velocity of those points, so what you can say is that, sir, this point will move in this direction. Okay, and this point will move in, oh my god, this point will again move in tangential direction. In tangential direction, both the points will move in tangential direction such that these angles will be 90 degrees and 90 degrees. I hope everybody understood so far. Okay, and similarly, if these lengths were L1 and L2, the distances were L1 and L2, then their velocities will be omega L1 and omega L2. Okay, omega L1 and omega L2. I hope everybody understood. I hope everybody understood. I don't know, Akash Dev. We'll see. Okay, I don't know the correct answer. We'll check. Okay. All right. Now, if the velocities are omega L1 and omega L2, and these two angles are 90 degree, we can use this to say something about any random body. Okay. If I take, let's say, a random body, okay, not this body, not, let's delete you. If I take, let's say, a random body, okay, let's just make a random body. Okay, and I don't know how this body is moving. Okay, this body is generally just moving and rotating and doing all sorts of things. Okay, this body is generally just rotating and moving and all sorts of things. Okay, but I do know this. I do know this that on this body I have these two special points A and B. Okay, and I do know the direction of velocities of A and B. Let's say I know that A is the first point is moving in this direction with a certain velocity, and let's say I know that this point is moving in this direction with this velocity. Okay, the body is moving in a very random motion, but these are the 2 points on this body, and I know that these are moving in these particular directions. Okay, now if you compare this to the previous diagram, if you compare this to the previous diagram, what I will do here is I will draw perpendicular here and I will draw perpendicular here. Okay, and wherever these perpendiculars intersect, what I will do is I will call this an instantaneous axis of rotation. What I will call this is an instantaneous axis of rotation. Guys, remember this is perpendicular and this is perpendicular, because what I can say is that, oh, I can assume that this body is rotating about this point at this instant. I can assume that this body is rotating about this point at this instant. Okay, this is not going to, it's not always going to rotate about this point. We don't know about what happens in the future or what happened in the past, but at this instant, I can say that the body is rotating about this point. Okay, this point is called instantaneous axis of rotation. Okay, and whenever guys we have instantaneous axis of rotation, we can use a very simple formula. We can say that the torque about instantaneous axis of rotation will be equal to moment of inertia about instantaneous axis of rotation into alpha. Torque about instantaneous axis of rotation will be equal to moment of inertia about instantaneous axis of rotation into alpha. I hope you guys are following. Oh my god, this is such a khatanak concept. Okay, so all right. I hope everybody understood. Now let's go back to this diagram once again. Let's go back to this diagram once again. Now, guys, if you see, there are 2 points on this body. I don't know how this rod will exactly move. Yeah, I really don't know how this rod will exactly move. But there are 2 points on this body. 2 points on this body whose velocity I know. There are 2 points on this body whose velocity I know. Okay, not exact velocity, but at least the direction of velocity. I know that when I release this rod, it's going to come down like this. Okay, it's going to come down like this. Therefore, this bottommost point is going to move in this direction. The bottommost point is going to move in this direction. Okay, I hope everybody can see this. I hope everybody can see this. Can you guys see? Can you guys see? Can you guys see? Yes. And next, if you look at the forces on this body, guys, if you look at the forces on this body, there is a force mg in downwards direction. There will be a normal reaction n in the upwards direction. Other than that, there are no other forces on this body. Can you see any other force on this body? No, they are not there. No, they are not there. So if there are only two forces on this body, and both of those forces are in vertical direction, then I can say that center of mass will only move in vertical direction. Okay, center of mass will only move in vertical direction because there is no horizontal force on this body. Okay, so since I know that as well, what I can write is that in that case, the center of this rod will also come vertically downwards. This bottommost point will move like this, and the center of the rod will come vertically downwards. I can say that about these 2 points. I can say that about these 2 points. Now, guys, go back to this diagram. If I know velocity of 2 points, then what I can do is I can draw perpendicular and find out an instantaneous axis of rotation. Okay, so that is what I will do here. I will draw a perpendicular to the center of mass velocity. I will draw a perpendicular to the bottommost point velocity, and where they meet, I will call that instantaneous axis of rotation. What I will assume is that at this instant, this body is rotating about this point. At this instant, this body is rotating about this point. Hina, this chapter is important for a NEET, but not at this level. This is advanced level question. Okay, this is an advanced level question. So what I can say is that this rod is rotating about this instantaneous axis of rotation. I can assume that at this instant it's rotating about this point. Okay, I hope everybody understood. I've just made a clear diagram here. At this instant, this body is rotating about this in this point. Okay, and let's say it is rotating with an angular acceleration alpha. It is rotating with an angular acceleration alpha. Now, guys, if I ask you how much is this distance, if the total length of the rod is equal to L, and I ask you how much this distance is, can you guys tell me how much this distance is? Can you guys tell me how much this distance is? If you see the total length is equal to L, then how much will this distance be? I know you guys can tell me in the chat. Tell me in the chat, guys. Tell me in the chat. What will be the distance? What will be the distance? That distance will be equal to L by 2. I hope everybody understood that distance will be equal to L by 2. And guys, if this angle is theta and this length is L by 2, then can you tell me how much will this length be? Can you tell me how much will this length be? Anybody in the chat, can you tell me? See, I will draw that again. Okay, if this is L by 2 and this is theta, then this length will be equal to L by 2 sine theta. Can you see that? This length will be equal to L by 2 sine theta. So here guys, this length will be equal to L by 2 sine theta. I hope everybody understood. I hope everybody understood. Okay, now, what do I do next? Let's try to mark all the forces. Okay, if you see, there are only two forces on this body. One second. Now, let me just remove this for a minute because the forces are supposed to be vertical. Okay, and forces are supposed to be green. There are only two forces on this body, guys. There are only two forces on this body. There is mg in vertical direction, and then there is normal reaction at this point in vertical direction. Are there any other force on this body? No, no, they are not. They are not. They are not. Okay, now here the equation that I can use, guys, here the equation that I can use is torque about instantaneous axis of rotation is equal to I about instantaneous axis of rotation into alpha. Okay, I hope everybody understood where the body will try to rotate like this. Now, if I ask you what is the torque about instantaneous axis of rotation, can you tell me what will be the torque about instantaneous axis of rotation? You see, this force mg has a torque about this point. This force mg has a torque about this point. That will be nothing but mg into L by 2 sine theta, and that torque is trying to increase the value of alpha. Okay, similarly, this and the normal reaction, is not, you know what, I'm writing the direction as well. Okay, direction is k cap. Okay, sorry, not k cap, minus k cap. Okay, because it's clockwise direction, and this n is passing through this line only. So if I ask you what is the torque due to n, that will be just 0. So torque about instantaneous axis of rotation will just be equal to my mgl by 2 sine theta in minus k cap direction. I hope everybody understood. Next, let's calculate the moment of inertia about instantaneous axis of rotation. The moment of inertia about instantaneous axis of rotation. Now, this is going to be hard, guys, but let's try to do that. Let's try to calculate moment of inertia about instantaneous axis of rotation. Now, guys, first of all, tell me, do you guys know, I will go to a new slide, I will make the layout as go. Do you guys know that if I have a rod like this and I rotate it about this axis, what will be the moment of inertia about center of mass? Can you guys tell me what will be the moment of inertia about center of mass? Thank you, Sandeep. Thank you. What will be the moment of inertia about center of mass? That will be ml square by 12. ml square by 12. Okay, it will be ml square by 12. Similarly, if I have a rod here, which is at an angle like this, and I ask you how much will be moment of inertia of this rod, can you guys tell me moment of inertia of this rod? Can you guys tell me moment of inertia of this rod? Moment of inertia of this rod will also be ml square by 12, guys. Moment of inertia of this rod will also be ml square by 12. Remember here, the rod is actually rotating about an axis which is coming out of the plane of the paper. Okay, the rod is actually rotating about an axis which is coming out of the plane of the paper. So about that axis, it doesn't matter if the rod is like this or the rod is like this. Okay, it doesn't matter if the rod is horizontal or at an angle like this. Okay, so I hope everybody understood. Really hope everybody understood. Okay. Yeah, you have to remember the formulas. You just have to remember. I'm so sorry. You just have to remember. Okay, so if I'm trying to calculate moment of inertia about the center of mass, guys, then moment of inertia about the center of mass is going to be ml square by 12. Now, what will be moment of inertia about instantaneous axis of rotation? That will be calculated using parallel axis theorem. I don't know if you guys know parallel axis theorem. Okay, what exactly is parallel axis theorem? The parallel axis theorem says that I about any axis is equal to I about center of mass plus md square. In this case, I about instantaneous axis of rotation will be equal to ml square by 12 plus m into L by 2 sine theta the whole square. M into L by 2 the sine theta the whole square. Okay, यहाँ पे L को capital L लिख देते हैं. This is capital L. Okay, not small L. Capital L. M into L by 2 sine theta the whole square. Okay, if I try to calculate this, this will just come out as ml square by 12 into 1 plus 3 sine square theta. Okay, I will, God. If I do the calculation, it will just become ml square by 12 plus ml square by 4 sine square theta. So ml square by 12 I will take common. This will just become ml square by 12 into 1 plus 3 sine square theta. If you do the calculation, guys, this is what you will get. Okay, you can trust me, I have done the calculation. Okay, you can trust me, I have done the calculation. Okay, now I will substitute this and the torque. I will substitute this and the torque into the main equation. Torque and this, both of them into the main equation. Okay, what is the main equation? What is the main equation? Torque about instantaneous axis of rotation is equal to I about instantaneous axis of rotation into alpha. Tau IAOR is equal to IIAOR into alpha. If you do that, guys, you will very easily get the value of tau, which is mg into L by 2 sine theta is equal to ml square by 12 into 1 plus 3 sine square theta into alpha. Now, from this equation, some things get cancelled out. M and M gets cancelled out. 1L will get cancelled out with L square. This and this will get cancelled out. 6 will remain. Okay, I will have a very weird answer, guys. I will have a very weird answer. I will get alpha is equal to 6G by L, 6G sine theta by L upon 1 plus 3 sine square theta. this will be equal to the value of alpha. This will be equal to the value of alpha. I don't know if you guys understood. I really don't know if you guys understood. Okay, now that I know the value of alpha, guys, I can calculate the value of, and now that I know the value of alpha, I can calculate the value of acceleration of center of mass. How will I calculate the acceleration of center of mass? So let's remove this. Let's remove all the unwanted stuff here. Okay, let's remove this as well. Let's remove this as well. Okay, yeah. So here, if you see, guys, if you see, the body is actually rotating. The body is actually rotating about this axis with angular acceleration alpha. That means the acceleration of the center of mass here can just be written as, the acceleration of the center of mass can just be written as r alpha, in which case the r is equal to L by 2 sine theta, because the distance is L by 2 sine theta, into alpha, which gives me the acceleration of center of mass as 3g by 1 plus 3 sine square theta. 3g divided by 1 plus 3 sine square theta. I hope you guys can see. I hope you guys can see. 1 plus 3 sine square theta. I can substitute. You want me to substitute? It will be L by 2. No, I can't substitute. Okay, just multiply L by 2 sine theta with this, and after some maths, you will get this answer. After some maths, you should get this answer. Okay. Shravani Reddy is asking, why, sir, can you tell me how to calculate IAOR equation? Shravani Reddy, IAOR we have calculated using, IAOR we have calculated using what? Where is IAOR? Where is IAOR? We have calculated IAOR using parallel axis theorems. Okay, we have calculated using parallel axis theorem. I know about this axis, the moment of inertia is ml square by 12, and I'm just shifting this axis by a distance of L by 2 sine theta. So I will just write ICM ml square by 12 plus m into L by 2 sine theta the whole square. If you do that, you will get the correct answer. Okay, if you do that, you will get the correct answer. Alright. I hope everybody understood. I hope everybody understood. Afra, there is no class. Akash, there is no 12th class today. Okay. Alright. There is no 12th class. There is no 12th class today. Okay, there's just class 11 stuff. Now, guys, this is once again a very hard advanced level question and also very confusing. Okay, this is a very hard advanced level question and also very confusing. Okay, so let's try to understand this question. Let's just first try to understand this question. A ring of radius r rolls without slipping. A ring of radius r rolls without slipping. Find the radius of curvature of the particle at the topmost point. Find the radius of curvature of the particle at the topmost point. Guys, first of all, if you are able to solve this question on your own at home, or if you have already solved this question, superb. I would love if you understood, if you already know how to solve this. Okay, but in case you don't know how to solve this, let's just first look at a rolling motion of a body. Okay, whenever you have a rolling motion of a body, if I follow one particle, then that particle will go along a path like this. That particle will go along a path like this. Okay, this path, by the way, has a special name. This path is called a cycloid. This path is called a cycloid. Okay, and when the particle is at this point, you have to calculate its radius of curvature. Now you might see this question and you will be like, sir, this radius of curvature is very simple. It should just be equal to r. If you say that, guys, you are wrong. If you say that, you particle, array, the point, not particle, a point on this ring. Okay, a point on the ring. If you follow its path, it will follow a path like this. That path will be a cycloid. Okay, you might look at this and you might be like, sir, this radius of curvature at the topmost point will be equal to r only. Guys, if you say that, you are wrong. If you say that, you are wrong. Okay, let me try to explain this first. Let's say I have a particle which is moving randomly on a blue path like this. I have a particle which is moving randomly on a blue path like this, and at any instant this particle has velocity v and acceleration a. Okay, now at this instant, guys, if I look at its acceleration, this acceleration can be divided into two components, the radial part and the tangential part. Okay, and if you look at what these accelerations do, so you have to understand that the radial acceleration is going to change the direction of motion of this particle, and the tangential acceleration is going to change the speed of this particle. Where do you study this, by the way? Where do you study this? You study this in circular motion if you have studied that chapter. Okay, and also if you just look at this path, guys, if you just look at this path, then I can make a circle which is tangential to this path. Okay, I can make a circle which is tangential to this path, and let's say that circle has a radius r. Then that radius r is called the radius of curvature of this path here. That radius r is called the radius of curvature of this path here. Okay, now how do I calculate this radius of curvature, guys? How do I calculate this radius of curvature? I will have to use the formula. The radial acceleration is equal to v by r, which gives me r is equal to v square by radial acceleration. Okay, r is equal to v square by radial acceleration, or you can just call it as r is equal to v square by perpendicular acceleration, v square by perpendicular component of acceleration. Okay, perpendicular component of acceleration. This is how we calculate radius of curvature of a path. Guys, I will repeat once again. If I have a particle going on a random blue colored path like this with velocity v and acceleration a, the acceleration can be divided into two components, the radial and tangential. The radial changes the direction, tangential changes the speed. Okay, now if you look at this path, you can make a circle which is tangent to this entire path. You can make a circle which is tangent to the part of this path. Okay, this is called this radius r of the circle is called radius of curvature of the path. It's called radius of curvature of the path. Okay, this radius of curvature basically tells us what, guys? It tells us how steep the turn is. Okay, how steep the turns are on this path. Okay, anyways, this radius of curvature, how do we calculate? We can write the radial acceleration as v square by r, which gives you the radius of curvature as v square by perpendicular acceleration. Okay, v square by perpendicular acceleration. Now let's look at this and try to apply this to our original question. If you look at our original question, guys, this is the path followed by the particle. Okay, now forget about all the other circles. This is the path followed by our particle. You know what, I'm going to make this red so that you can follow. This is the path followed by our particle. This is the path followed by our particle. Okay, now forget about all the circles, just look at this path. If you see, I can draw a circle which is tangential to this path. I can draw a circle which is tangential to this path. Okay, let me draw that circle in blue color. Okay, I can draw a circle which is tangential to this path, and the radius of that circle will be the radius of curvature. The radius of that circle will be called the radius of curvature. Now that value will not be equal to r, it will be some other value, let's call it r dash. Okay, if I make a more clearer diagram, that value will be some other value r dash. This circle is supposed to represent the tangent to the path, not tangent to the circle. Okay, I hope everybody understood. Okay, Akash Dev, no, the answer is not 2r. Okay, so now how do we calculate this, guys? Once again, we will just use this formula only. We will just use this formula only. R is equal to v square by AR. Okay, let's try to use this. Now, in order to understand this, first of all, let's look at a rigid body. Let's say I have a rigid body, and this rigid body is rotating with angular velocity omega. Then all the points on this body will have acceleration. All the points on this body will have acceleration towards the center called omega square r. All the points on this body will have acceleration called omega square r. Okay, now if this body is actually rolling on a floor with constant velocity, then the situation will be something like this. Here, it will still be rolling with angular velocity omega, and the angular acceleration will still be omega square r. Okay, and the velocity will be equal to v. Now the body is actually rolling. Here it was not rolling, here now it's rolling. Okay, not rolling, rolling, not rolling, rolling. And when it is rolling, there is a relation between v and omega that we can say is v is equal to r omega. V is equal to r omega. Now guys, this is the first point you have to remember. This is the first point you have to remember. You have to remember this equation. You have to remember that the acceleration of this point is equal to omega square r and v is equal to r. Okay. Also at the same time, guys, I don't know if you have seen rolling motion before. Yes, Akash, the 4R is correct. I don't know if you have seen rolling motion before, but if you have seen rolling motion, the speed of the topmost point is always 2v. The speed of the topmost point is always 2v, where v is equal to r omega. Okay, so if the speed of the topmost point is always 2v and the acceleration of this point is equal to omega square r, I can easily calculate the radius of curvature of this point. What will be the radius of curvature? I can write radius of curvature is 2v the whole square divided by the radial acceleration, or 4v square divided by omega square r. Now, if v is equal to r omega, I can write omega is equal to v by r and substitute in this equation. When I do, r dash will come out as 4r. R dash will come out as 4r. That is it. Okay, that is it. This is the radius of curvature of that point, not of the body of that point. Okay, so guys, at this point of time, let's talk for 2 minutes about Vedantu's platform. If you're preparing for JEE 2021 and 2022, Vedantu's platform is just for you. It's the best platform. If you get our pro subscription, you get full access to all the live courses where all the subjects are covered in great detail. You get to choose the language in which you want to study, Hindi or English. You have instant and infinite doubt solving in class. We have as just like master teachers, we have also something called class teachers in class who are there just to solve your doubts. You can ask them infinite number of doubts, they will always solve. And you get to study from India's best teachers, all of them having more than 5 years of experience, and you get to study from home on any device you want. Okay, so what do you have to do? What do you have to do if you want to get on Vedantu Pro subscription? You have to go to vdnt.in/ytpro. You have to go to vdnt.in/ytpro and use my coupon code AAPPRO. Use my coupon code AAPPRO. Guys, when you do that, you get the I still have 2 more questions to go. Okay, I still have 2 more questions to go, by the way. When you do that, you get discounted price. You get discounted price. Okay, all right, guys. All right, so next, let's talk about this. Let's talk about the next question. Okay, now next question is a super terrible question, but we will do this. Okay, this question I don't like because it involves angular momentum. Okay, and I personally hate angular momentum, although it makes things very easy. I hate it, but still, let's try to solve this question. Okay, let's try to solve this question. Okay, so I have a sphere which has a radius r and which is placed on a rough horizontal surface with given velocity v naught and angular velocity omega naught as shown. The sphere, it is kept on a rough horizontal surface like this. Okay, it was rotating like this and going like this, and it's kept on a horizontal surface. So it moves up for some time and then comes to rest. It moves for some time and then comes to rest, which is understandable. Okay. Anyways, if it comes to rest, you have to tell me the relation between V naught and omega naught R. You have to tell me the relation between V naught and omega naught R. This is the only question, guys, where I have given the options. But we will once again not look at the options. Option matching nahi karna hai. We are not those type of people. What we will do is we will solve it properly. Okay. Yes, shallow case pure rolling is possible on smooth surface. Okay, here it's not on smooth surface, by the way. Here it's on a rough surface. Here it's on a rough surface, not on a smooth surface. Okay, anyways, guys. So in order to understand this question, what you need to do is you need to understand angular momentum. And let me give you a crash course on how to calculate angular momentum for such bodies. Okay, this is a body which is moving and rotating and doing everything at the same point of time. So let me give you a crash course on how to calculate angular momentum. Okay, so first of all, let's say I have a point mass moving with velocity v, and I want to calculate its angular momentum about origin. Let's say I have a point mass which is moving with velocity v and I want to calculate its angular momentum about origin. Okay, so what will be its angular momentum about origin? Angular momentum is given as, it's written as L, and that is basically equal to R cross P. Okay, which in this case, if I just talk about magnitude, it will just be RP sine theta, where P is the momentum, or it will just be MV R sine theta, R into MV into sine theta. Okay, I think everybody knows this. This can just be very simply written as L is equal to mvr sine theta. This is the angular momentum of this body about origin. About what? About origin. Angular momentum is always calculated with respect to with respect to what? With respect to a point. Okay, now if I want to write down the vector form of this, if I want to write down the vector form of this, I want to know the direction and everything as well, then you have to remember L was equal to R cross MV. Okay, so you have to do cross product of R and V. If you make R, what exactly is R in this case, guys? What exactly is R? R is this way. So what will be R cross V? What will be R cross V? You have to do R cross V, R cross V, R cross V, R cross V. Where is your thumb pointing? Where is your thumb pointing? Oh, it's pointing into the plane of the paper. Okay, so if you write it in vector terms, you have to write it as MVR sine theta, MVR sine theta minus k cap. Okay, MVR sine theta in minus k cap direction. I hope everybody understood. I hope everybody understood. Okay. Now, this is for a point mass. Point masses are easy. What do we do if we don't have point masses? Okay, what do we do if we don't have point masses? Well, let's say I have a big body, but this body is not rotating. This body is just moving, it's not rotating. I have a big body, it's just moving, and its center of mass has velocity v. Its center of mass has velocity v. Then once again, its momentum about angular momentum about origin is just mvr sine theta. Once again, its angular momentum about origin is mvr sine theta. If you write it in vector form, it will be mvr sine theta minus theta. Okay, this is a body which is moving but not rotating. This is moving but not rotating. Okay, now if I have a body which is rotating and moving at the same point of time, moving and rotating at the same point of time, then in this case what do you do, guys? You just take this, if I start rotating this body as well, then you take this and you add one more term to it. You just add one more term to it. Okay, what is the term that you have to add? What is the term you have to add? The term you have to add is ICM into omega. Okay, or I into omega. Here पर ICM means just moment of inertia about center of mass. Okay, just have to add one more term, ICM into omega. Now in this case, this is rotating in anti-clockwise direction, which means your thumb is pointing out of the plane of the paper. Did you see your thumb is pointing out of the plane of the paper? So that means omega is in plus k cap direction. Omega is in plus k cap direction. So ICM omega will have a direction of plus k cap. ICM omega will have a direction of plus k cap. Similarly, if the body was rotating, going like this with velocity v and rotating in the opposite direction, then in that case, you will write L is equal to mvr sine theta minus k cap plus ICM omega also minus k cap. Why? Because now the body is rotating clockwise. That means your thumb is pointing into the plane of the paper. That means omega is in negative k cap direction. Okay, this is how you calculate. This is how you calculate angular momentum for rigid bodies. Angular momentum for rigid bodies. Okay, now remember this, guys. Okay, now coming back to this question, if I look at this question, on this body there is just force at the bottommost point. There is just force at the bottommost point, and it's a frictional force, and there is another force, normal reaction at the bottommost point. Okay, there are no other extra forces. So in this case, what I can say, guys, is that before it stops, and finally, initially and finally, the angular momentum about the bottommost point, okay, will be same. Initially and finally, the angular momentum about the bottommost point will be same. Okay, initially and finally. Alright guys, I hope everybody sees this. I hope everybody sees this. So now let's try to calculate the initial momentum about the let's try to calculate the initial momentum initial angular momentum about the bottommost point. Okay, so I will use the equation L, let's write it as I. Okay, L is equal to what? It will be equal to first m into v naught into r, and if you see r, what will be the what will be the direction of r? It will be like this, and r cross v, do you see in which direction it points? R is up, v is towards right, r cross v will be into the plane of the paper, so it will be minus k cap. Okay, and finally guys, if you see, finally if you see Finally, if you see, because of the rotation, I can write plus ICM into omega naught. Now, omega naught is rotating like this. Oh, it's rotating anti-clockwise. So, its angular momentum will be in which direction? The rotational angular momentum will be in the plus k cap direction. Okay, now if I write this properly, guys, this will just be equal to minus mv naught r. Okay, plus this is a solid sphere, right? What is moment of inertia of a solid sphere? What is moment of inertia of a solid sphere? Can anybody tell me? Oh, it is 2 by 5 mr square, you say. Are you guys sure? Are you guys sure? Oh, okay, if you say so, I will believe you. I will believe you. Okay, and finally, the body is at rest only. So, final angular momentum will just be equal to what? Zero. Okay. Uh, there is no torque. See, there is a force, but about this point, if I calculate the torque about this point will be zero now. Psi location, there is no torque about the bottommost point. Do you see? There is no torque about the bottommost point. That's why the angular momentum about the bottommost point is zero. Okay, I hope everybody understood. I really hope Psi location understood. Okay, so guys, I will just do this. I will just write Li is equal to Lf. Li is equal to Lf, which means this entire thing is equal to 0. This entire thing is equal to 0. Okay, which if I try to solve, it's very easy to solve. Which if I try to solve, it's very easy to solve. What I will just get is I will take one of the things in the next other direction. Okay, let's just k cap will just immediately go away, and let's just take this in the other direction. So I will just get this, this is equal to mv naught r. Okay, now m and m will get cancelled out, one r will get cancelled out with one r. Okay, and I will just get final answer 2 omega naught is equal to 5 v naught. Okay, 2 omega naught r is equal to 5 v naught. Okay, if you look at the options, guys, if you look at the options, see, these are advanced level questions, so it will take time to solve. Okay, but if you look at the option, you will get option B as the correct answer. Okay, 5 omega naught r is equal to 2 v naught. 5 omega naught r is equal to 2 v naught. I hope everybody understood 5 omega naught. Sorry, 2 omega naught r is equal to 5 v naught. What you doing, Pandya? What you doing? What you doing? What you doing? Not this one, not this one, this one. Option C, option C. Yeah, sorry. Yeah. मेरी गलती थी यहाँ पे, मेरी गलती थी. Yeah. Psi okay, pseudo torque is just torque applied by a pseudo force. We don't much worry about it. Okay, don't ask me such questions. I don't know. I've never seen pseudo torque before. Okay, all right. AI gamer, current electricity one shot. Okay, current electricity one shot tomorrow. Don't worry. Now let's do the last question, guys. Let's do the last question. This is more of a conceptual question than a proper question. Okay, I have then a calculation intensive question. I have, what do you call it, a smooth ground here, but a rough surface on the top of the plank. I have a smooth ground here, but a rough surface on the top of the plank, and I'm applying force on a plank. Now, when I apply force on this plank, guys, you have to tell me which of the following statement is incorrect. Which of the following statement is incorrect? Okay, now this is a very conceptual question. You don't need to worry that much about what is happening. Let's just try to understand. Okay, now what they are saying is the sphere does not slip on the plank. Okay, it does not slip on the plank. Okay, does not slip on the plank, meaning what? This sphere here is doing a pure rolling. It's doing a pure rolling. Okay, now you have to tell me which of the following statements are incorrect, which of the following statements are correct. So one by one, let's check if any statement is correct or incorrect. Okay, now the first statement is that if both these are moving with different accelerations a1 and a2, if both these are moving with different accelerations a1 and a2, the first statement says that A1 will be less than A2. Guys, can you tell me if this statement is correct or incorrect? Can you tell me if this statement is correct or incorrect? Can you check? Do you know how to check? Do you know how to check? Hmm. See, this statement is true. This statement is true. Why am I saying this statement is true? Guys, what will happen is, let me just make this diagram more bigger. Okay, I like bigger diagrams. Oh yeah. Yeah, let me just make this diagram more bigger and remove of this a1 and a2 for 1 minute. Okay, so guys, what will happen is that when I start applying a force on the plank, the there will be a force of friction due to the sphere on the plank in backwards direction, and due to there will be a force of friction due to the plank on the block on the sphere in this direction. Force of friction will look something like this. Okay, now, because of this force of friction, this sphere will have an acceleration in this direction. It will have an acceleration in this direction, and it will have an angular acceleration alpha in this direction. Also at the same time, guys, also at the same time, okay, the plank below has an acceleration. The plank below has an acceleration a2 in this direction. Okay, I hope everybody is following. I hope everybody is following. Now, if I talk about that, let me just remove this force for a minute. Okay, if I talk about the acceleration of bottommost point of the sphere, if I talk about okay the acceleration of bottommost point of the sphere, it will be a1 in this direction. It will be a1 in this direction due to the motion of the sphere plus r alpha in this direction due to the rotation of the sphere. Okay, and since there is no slip between the two of them, what I can just write is that a1 plus r alpha is going to be equal to a2. Now, if you see this, guys, this means that A1 will be smaller than A2. That means our statement will be true. That means our statement will be true. Okay, next chapter, guys, more hard problems on current electricity. Okay, I will give you a choice. Don't worry, I'll give you a choice. Okay, so the first statement is true. Next statement, work done by friction on the sphere is equal to its total kinetic energy. Now, if you see once again for the second statement, guys, if you see the second statement, then you have to once again, let me make this diagram bigger up once again. Let me make this diagram bigger once again. Okay. So if you see on this sphere, there is only one force in horizontal direction. There is only one force which is going to do some work, that is the frictional force. Okay, and this is the force because of which the sphere will start moving. So I can just very simply say that work done by friction will be same as kinetic energy of the sphere. Work done by friction will be same as kinetic energy of the sphere. Okay, I hope everybody understood. I hope everybody understood. Okay, that will be same as kinetic energy of the sphere. So the second statement is also true. The first statement is true. The second statement is also true. Next, uh, yeah. Hi, Kavya, hi, Kavya. Kavya, I can take 2 lectures in a day, my friend, and I wanted to take advanced level lectures. Okay. All right. Next, total kinetic energy of the system. The next statement is total kinetic energy of the system is equal to work done by F. Now, this also makes sense, guys. This also makes sense. Okay. What am I saying? What am I saying? That if you look at this, there are three different forces. Okay, there are three different forces. First is a friction in this direction, second is a friction in this direction, and third is the force F which we are applying. Okay, now if you check this, you can check this work done by friction on sphere will be equal and opposite to work done by friction on plank. Why? Because on one, the force on the sphere, the force is in right direction. On the plank, the force is in left direction. But the displacement is the same for both. After some time, if you look at the displacement of this bottommost point will also be this. Displacement of this plank will also be this. Okay. So one work will be negative, one work will be positive. The work will be equal and opposite to each other. Okay. So what I can say is here the total kinetic energy of the sphere plus kinetic energy of the plank, okay, will be equal to work done by the force F plus work done by the force of friction on sphere plus work done by the frictional force on plank. Okay, and I know that these two will just cancel each other out. So overall, what will I get? Overall, I will get kinetic energy of the system. The total kinetic energy of the system will be nothing but work done by the external force F. So therefore, this statement is also true. So which one of the statement is incorrect, guys? Which one of the statement is incorrect? The incorrect statement is none of this. None of this. Okay, Sai Lokesh, yes, I will try to do that. Okay, my friend, I will try to do that. I will try. Okay, so these are the top 5 questions. The 5 questions that I found hard and also had a lot of conceptual work. Okay, I have done these 5 questions today, guys. I'm going to share these notes in some time. Okay, and I'm going to stop this class today. But before I go, I want you to tell me one thing. Tomorrow also, I want to do 5 questions. Tomorrow also, I want to do 5 questions, okay, which are advanced level. You tell me which chapter. Okay, I will give you 2 options. The first option is current electricity, and the second option is ray optics. Okay, these are the 2 things that you said in the chat. Okay, yeah, I know. Russell is correct. Russell is correct. Okay. Current electricity, you want me to do advanced questions tomorrow or ray optics? Tell me, guys. Tell me. Hamsat was is saying current electricity. Mohammed is also saying current electricity. So I have one and two votes here and 2 votes here. Okay. I need a one breaking vote. Tell me which you want me to do. Okay. Oh my God. So many. Silokesh, you can only give vote once. Okay. Sakshi is also saying current electricity. Okay. Ashwin Nair is saying ray optics. Oh my god. You can only vote once, guys. You can only vote once. Tell me one. I need a tiebreaker. Mohammed Fiaz. Okay. Hamsat Waj has already said E. No? Hamsat Waj has already said E. Okay. Ishita Goyal is saying Ishita Goyal is saying option B. Okay, and Mohammed Fiaz has said option A. Okay, so once again, I have tied. Okay, guys. Okay, so you know what? I'm going to do this tomorrow. Okay, and I'm going to do this day after tomorrow. Okay, both these five advanced level questions from these two. Okay, that's where I'm going to stop. That's where I'm going to stop. The voting stops now, guys. So okay, I will do five questions. Okay, and I want to start taking two classes every day. I will do that very soon. Do not worry. Okay, I will start doing that. I will start doing that. Okay, that's it for today's class, guys. If you have any doubts, you can write them in the comment section. If you have any doubts, by the way, you can also contact me. If you have any doubts, you can also contact me on Telegram. Okay, you can also contact me on Telegram at AADITYAP 832. This is my personal chat on Telegram. You can directly ask me doubts on this. I will respond as soon as I can. Okay, sure. I will try answer. No, not tomorrow, my friend. Not tomorrow. Not tomorrow. Not tomorrow. Okay. All right. Sai Lokesh, I will try. I will try. I will try. Okay, sure. All right, guys. So I will see you tomorrow. Have a nice day, and I will stop here. Okay. Bye bye. Bye bye. Bye. Bye.